presentation will be touching on areas which will quite diverse areas, because metaverse is a very diverse area. How many of you have a understanding of what a metaverse is? Okay, great. So let me give an intro. So before that, so essentially I had AI at Hike, but also I am co-founder at multiple companies here. So over time, I thought startups is an interesting area. So I've been diving further in that space as well. So what we'll cover essentially are what is a metaverse, what are the features, the experiences, development stages, forms of reality, who are the players, what are the applications. Then we jump into AI, the most interesting part, which correlates with the conference pretty good in a much better way. So we'll have interesting aspects about in the metaverse when you simulate a reality, what is the 3D content generation, what are the needs for it, why does it need to be so, in order to make it a reality for all the business models and all the applications, what do we really need to do, and what are the various forms of models which are actually being used worldwide, and what is the progress and what are the players and how deep are they already entrenched into this space, followed by challenges and conclusions. So metaverse basically is so for quite some time, we have had various parts of progress in this field called metaverse. It got coined very recently, but if you really see, the technology has developed over huge number of years, many number of years. When I say huge, I don't mean like 50 years. What I mean is like 10 to 15 to 20 years. So basically, what has happened is that you had Second Life, and I'll go through the development stages of metaverse as well. But as an overview, you had Second Life around 10, 15 years back, or slightly more back in the past. And there we had these aspects about augmented reality and virtual reality developing. And over time, we had multiple devices and interfaces like Google Lens, Microsoft HoloLens, and so forth, which have made and utilized the enhancements in hardware, device, the interfaces to be able to give you that capability to experience something that is a metaverse. Basically, it's a reality, it's an alternate form of reality, which is basically enabled by the digital world. And you kind of are then able to combine the aspects or the environments or the activities in the physical reality where we are right now into the digital reality. And it combines the things together. And the whole game is how do you make it feasible? When you make it feasible, it has to be economically feasible, it has to be materially physical, which basically, or possible, which basically means that the technologies have to support it, the underlying latencies, performance, the technologies, the whole infrastructure, the security, the privacy, all of these things have to come together to enable it, and then the whole business ecosystem has to support it. If any of these things are not happening, basically that stuff is going to fail. So we are going to see as an overview what are the various characteristics of the metaverse which actually get these things together. So some characteristics are that it is boundless. Basically, it goes beyond the physical space to the digital space and kind of merges them together. It is decentralized. So it is not like our typical banks and all, which are kind of centralized systems, or governments which are more centralized. It's a whole decentralized economy or decentralized system, essentially powered by blockchain, right? It is persistent, so it exists at any time, in any place, in the virtual place and the physical place in some sense. The economic system is all supported by virtual economies. So you have the blockchain, which is powering multiple types of tokens, the tokens, the blockchain tokens, and then the NFTs, which are non-fungible tokens, which kind of increase in value by itself, and they're not similar to each other. And all these different types of tokens that we have seen evolving over the last 4 to 5 years have created a lot of buzz, both on the positive side and people losing quite a bit on the negative side of it as well. But fundamentally, they are enabling these virtual economies, which have a lot of advantages, as we will kind of see. It is immersive, is that you basically pretty much are part of the system. It is not like the typical devices which we are used to in the past for the last 20, 30 years, starting from the old desktops to the laptops to the mobiles, and now this is getting pretty immersive. And we'll see multiple examples of this. And it is social in nature. So there are a lot of social experiences, which means basically there's an interaction between our digital selves, our physical selves, and the virtual beings, which are the bots, right? So all of these three types of beings, if you will, they're interacting over there and creating something interesting, which keeps our mind engrossed in it and which creates this whole ecosystem. So the experiences, a lot of you would have seen this in one way or the other. We have Shopify, which has e-commerce experiences. You can feel yourself, in this space here. We can see us. We can, through appropriate, devices or interfaces, you can see how a sofa would look like, what kind of various paintings there would look like. So it's a very immersive experience. Shopify has enabled that. for virtual work, either it's 2D or 3D, and now 3D being enabled by the devices and the power of computing and the networks. The 3D graphics approaches are basically will be enabling you to kind of work together in a collaborative way, especially in the kind of environment we are used to in a hybrid mode. And obviously games, which are, there are a huge number of examples, including Fortnite. So the development stages of metaverse, the key kind of development stages, started with the birth of the internet, obviously the core infra, which kind of matured over from Web 2 on to Web 3, and we'll discuss Web 3 over there. It went into proof of work, digital twins, then essentially Bitcoin coming in 2009, the core fundamental premise of what a virtual token should be, of what a virtual economy should kind of behave. And there are lots of pros and multiple cons of this as well, as we are seeing, and people losing money and also a lot of opportunity to gain money. But fundamentally distilling into the blockchain technology around 2009, the same year. And that blockchain technology is the fundamental basis on which the whole decentralized aspects are enabled, the whole decentralized finance is enabled, the whole distributed organizations have been enabled. So as we go further, you have augmented virtual reality coming into picture. In fact, you had a 2003 Second Life kind of a paradigm that came into being, but that vanished because not all the parts of the ecosystem supported Second Life. So we did not have networks which were that fast at that point of time. We did not have the cloud technologies at that point of time, which were so kind of enabling it in a very pervasive sense, right? We did not have blockchain. So that's why Second Life, though it has a very similar connotation, did not succeed. But now as you go further, you see the upcoming of non-fungible tokens. This plays a very fundamental role in how it impacts the whole economics of the virtual economies in a system like a whole metaverse, right? Then we had Oculus VR, a very important kind of a development over there. We had Microsoft HoloLens, which many of you would have seen or should now see the Microsoft Mesh, which is coming towards the end over there, which has very interesting set of kind of examples of what you could do in a metaverse, how you could build apps in such a short amount of time and so forth. Then going further with Ethereum, which is a very big improvement, which was a very big improvement over blockchain at that point of time in 2015. And later we had, in fact, not mentioned over here, are additional blockchain technologies like Polygon, which make it much faster, and the associated chains as well, Solano and so forth, which make it much efficient and much faster way to be able to operate on the blockchains. Going into Pokemon Go, which I think I'm sure all of you would have heard in terms of augmented reality, a very engaging game, right? Then decentralized organizations, Fortnite, virtual games, Axie Infinity, a very interesting game which is played only on tokens and NFTs, and it was $1 billion valuation during COVID time within a year, right? Right now, they are not doing that good because the way they manage the economy in the system is something that has to be explicitly considered, which is kind of correlates to the economy system that we see in the world right now, partially going into a recession and stuff like that. So that is another aspect of a metaverse in which you have to manage the economy so that the system actually is able to sustain itself for a longer time, which if you don't do, then you could get into kind of a system that Axie Infinity is in right now. But a very fundamental core kind of an evidence of how a metaverse could evolve and what is the strong potential of metaverse, at least from a gaming standpoint or distributed apps standpoint of view. Now we have Microsoft Mesh, we have Meta Platform, we have NVIDIA Omniverse, and we have downstream improvements. We recently had an Ethereum merge, which basically makes the Ethereum much more efficient from proof of work to proof of stake. So that helps in multiple ways for the evolution of the whole system, and it enables metaverse in a very strong way. So this is the various a set of kind of various fundamental kind of cornerstone milestones for metaverse, but there are a lot of enabling technologies which are not mentioned here, which will, as we go, we'll discuss about it. So just to overview on forms of reality, we have augmented reality in which you have kind of a physical 3D content in a kind of overlaid on top of the current reality, let's say in the current reality, but it may not be that much environment aware. We have mixed reality, which is heavily environment aware. Imagine a drone flying through all of us, but being very aware, even that digital entity called drone does not touch any one of you in any way, right? Then we have virtual reality, which all of us are aware is totally immersive into a virtual world, totally different world, and extended reality, which kind of combines this whole spectrum right from augmented to extended. So the 7 layers of metaverse, as I was mentioning. So at the core infra, you have these networks which are very fast, which are evolving from 5G to 6G, and we heard 8G also in one of the talks earlier. Then going into the manufacturing technologies, going from 7 nanometers to 4 nanometers, even going to more deeper, which is like quantum circuits and so forth, enabling more types of powerful characteristics which can derive the elements of the stack upwards, and the core aspects of it, which is MEMS, GPUs, materials, and so forth. From that hardware base, we come to the human interface space. We have seen lots of technologies, especially the recent ones like Neuralink, how it connects with the brain. Then going with more non-invasive stuff like haptics, gestures, voice, and so forth. So it gives a way for all of us to be able to interact into that digital kind of reality. Then decentralization primitives enabled by microservices core in the cloud, blockchain for the whole distributed system, and the secure distributed system, edge computing, AI agents, right? That powers into the spatial computing, which takes or kind of involves 3D engines, Unity, Unreal, all the ways in which you model a 3D reality. Then VR, AR, XR, which we just discussed, multitasking, geospatial mapping, and AI at that level. And at this point, we are going to discuss further on this particular level further in the slides. The creator economy. The creator economy is an extremely important one where the whole power of decentralization and the blockchain gets leveraged, and you are kind of enabling people to create, being able to independently operate in the system rather than being dependent on a centralized system, and being able to run and make their own business in an interesting way. So the creator economy essentially is getting enabled by the whole blockchain kind of infra, which has design tools, asset markets, workflows, commerce, and that essentially also goes into the aspect of having or being able to design an interesting economy in the blockchain or the metaverse. And we'll cover some aspects of it as we go further. The discovery part is about how do you discover all these services with the social curation, stores, agents, and so forth. And finally, the experience, the applications that we have seen, the distributed applications, which goes into games, the most important ones, which have, one of the most important ones which have funneled the evolution of the metaverse to this level of maturity. Social, esports, theater, shopping, and there are lots of applications in manufacturing and so forth, right? So this is the whole structure of the metaverse. And as you can see, Second Life, which was there in 2003, did not succeed because many of these factors simply did not exist, right? And now we have it, so actually we can talk about it and see it. So these are the players in that structure. At the infrastructure, we have AWS, Azure, NVIDIA, and so forth. At the human interface, we have seen Oculus, HoloLens, Xbox, and so forth. Then essentially we have Microsoft, Eva Labs. For spatial computing, we have Unity, Unreal, all the 3D modeling and geometric, modeling games, the corresponding AI primitives and the AI kind of capabilities over there. The creator economy, the discovery stuff, and the experiences, right? And so a lot of these areas have a huge market potential. So metaverse itself has trillions of dollars of market potential within the next 10 years, right? So that's why it has become a big buzzword. And the blockchain in particular with distributed apps and the distributed economy is enabling the whole, ensuring that the blood flow as such in this whole system is pretty solid, right? Which means the systems will thrive on their own, and the system will be able to kind of lead to a productive, efficient kind of involvement for all of us. Okay, so from an application standpoint, just going into some specific areas of applications or verticals, we have e-commerce, where we have seen in the earlier slides, virtual stores, an interesting immersive shopping experience, obviously a hyper-personalized customer experience. Going to healthcare, which is pretty much through remote diagnostics, remote kind of operative practices, to actual core AI functions, which is essentially across predicting, onset of risk conditions, onset of diseases much in advance, being able to, have virtual health centers and hospitals. To decentralized finance, this came up very recently in the last 4 to 5 years. This is pretty much powered by cryptocurrency, leaning, borrowing, farming, staking, decentralized exchange and applications, and using NFTs, in which you essentially are basically able to get more value out of a particular token based on the context of an ecosystem, that tokens get high value, and therefore you are able to get much better monetary output from that particular investment. So DeFi is an interesting one. In gaming, we have seen all the interfaces with procedural content creation, 3D content creation. Real estate is also very interesting. How many of you have heard about Decentraland or investing in virtual real estates? Okay, so this is a interesting but seems bizarre concept. You have land in a virtual kind of digital world. You can buy that land, have an NFT. And you can borrow that land for someone else to kind of play games. So you earn money. You can loan that land and so forth. So there's a whole economy that is created by a land that is only in the virtual space, right? And if you can link it to corresponding physical land in the real space, then it can get even more interesting. Going towards smart cities, basically simulating the smart cities. We had a talk earlier talking about Singapore putting up a brain for managing their smart cities, right? Then we have video surveillance, a lot of the typical AI applications sitting over there. In human resource, we have virtual job fairs and the corresponding aspects. Again, full integration across all of these with the speech, vision, and also NLP. And then manufacturing has very interesting applications with 3D printing, again fault diagnosis from a remote kind of a setup, a fully kind of immersive kind of applications of it, and so forth. So the AI applications in particular, there is some sampling of it. This is not a complete set. On the NLP side, we can do language modeling, word prediction, speech processing, semantic labeling, and being able to understand the language semantically and being able to communicate and translate the languages in that space in the metaverse. In machine vision, there are a huge number of applications, and these essentially we'll look at more detail and the models that are used over there. And this can be object segmentation, image restoration, pose estimation, action recognition, to name a very few of a very large set. Obviously, we have virtual augmented mixed reality, which takes a full kind of capabilities from computer graphics, computer vision, to be able to understand a whole scene, understand the objects in the scene, understand the behaviors in the scene, to be able to recreate those behaviors, learn those behaviors automatically, and recreate in a system. So we are going to see this focus of the remaining part of the talk will more on these two parts of it. And then essentially we have blockchain, where we do have privacy, security, fundamental core capabilities of the blockchain being able to kind of enable distributed apps, and then it can leverage AI and enable AI in a much more efficient fashion on a blockchain type of a system. Going to networking, where 5G, 6G, they all leverage AI and machine learning at the core of the design of those networks, versus the prior generation networks like 4G, LTE, and so forth. So here AI is being used core inside the whole design, and then going further, obviously it has more hardware-oriented acceleration. Then we have digital twins and brain-computer interfaces. How many of you are aware about Neuralink? Okay, so you should read that. So it has both invasive, non-invasive signals, which means with the brain being able to control a kind of a device, you can have non-invasive, which is just a kind of a cover, invasive, in which electrodes, which very fine wires are in the brain, and you can not only read the brain, you can also write the brain, which kind of becomes an ethical issue. But this has a lot of applications, and people like Musk and all are pretty aggressive in driving those. So coming to the AI and computer vision part of it. So essentially, what you want to do in the metaverse, that you should be able to create an immersive environment, right, at scale, with high efficiency, high productivity, low cost, low power, and it should be very real to you, and it should be very natural to you as a human, right? And that is where the whole interfacing can happen, and whole involvement of the various types of beings that I mentioned, right? Our physical self, our digital self, and the digital beings, the bots themselves, they can interact in that space. So there are multiple applications which can require, and there can be more than this as well. So you can have, you can have seen the filmmaking industry. Obviously, games, you need that kind of a immersive experience. In architecture itself, how you design the architecture, what would it look like? Then you have VR, we have seen examples of that. Then we have healthcare and robotics. Robotics is very interesting because to be able to train a bot for self-driving, you need to be able to simulate the whole environment through which the bot goes before you launch that self-driving car. So in robotics, whatever environment that the robot has to execute in. That whole context has to be created in a simulated way, right, inside the lab. And that's where that 3D content generation and creation is very useful. So we'll study or go through the slides a bit of it. So this is a research that I'm presenting by Sanja Fiedler, and she's an assistant prof at University of Toronto, and she presented this in Europe's 2020, a couple of years back. And so this is all about 3D content generation. So if you have to create such a metaverse, how do you first generate the content for it, right? So what is really there in the content and what's the need for it? So Grand Theft Auto, how many people are you aware of Grand Theft Auto here? Pretty much all of us have played it, right? So it took 1,000 people 3 years to create all these scenes, the behaviors, the 3D objects, right? And making it as realistic as possible as you play in the game, right? So imagine the amount of effort it took to create that whole thing, right? And so it is extremely slow. If we were at this space, right, there's no metaverse that we would have thought of right now. The whole buzz would have not existed, right? So what we are saying is that AI is enabling, right, in this fashion, I'll go into these details, on how to be able to simulate the complete cities, right, which are all the structures in the cities, all the attributes of a building, the shape, the texture, the lighting, the brightness, darkness, the various environments, the weather, right, the behavior of the people, the behavior of the cars and systems inside it, right? So can you simulate these cities so that you can put in a metaverse, right, in a very efficient way, you create the whole system, and that's how you enable a more meaningful metaverse, right? So what you want to synthesize, or what you want to be able to synthesize, is you want to be able to compose the scenes, figure out the scene layout, right? How are the objects placed? What are the objects? These are cars, these are buildings, these are lanes, and so forth. We'll see some examples of that. Being able to create those assets. So creating each asset in a 3D model. How many of you have played with 3D models or done some work on 3D models? Okay, cool. So basically, when you have to paint a picture in a 2D, right, you have to see a projection of, some object, let's say, this speaker. You have to create a projection of this speaker or even a human face, right, and you have to draw how the eyes look and so forth. When you have to create the same thing in 3D, the way we are doing stuff in Hike, basically you have to create the mesh, right, the 3D mesh, how the eyes, the structure of the eyes looks like, the nose looks like, the hands look like, and so forth. That's for a human. And for any object, you have to create the 3D mesh, you have to create the bones, because that object is non-rigid. The various parts of the object are moving relative to each other, they are translating with respect to each other, right? And you basically have to make sure that it works in a very cohesive fashion with respect to the physics of the whole 3D object, right? So it's a very complex process, and that's why it is very slow, and that's why it took time, because it is a lot of hard work, right? So the question is, can you have an AI system which does 3D content generation? Can it generate these assets, right, which are the objects or the scene elements? Then you have to create scenarios which are positions and the goals of the actors. What are the actors doing? What are their behaviors? How do they behave? What is the animation? What is their capability, right? So based on the bones of the person, he can do only certain set of things. He can't do some other, kind of movements, right? There's some limitations of the physics and so forth. So what we are trying to do essentially is we are trying to look at how people are trying to explore 3D content generation, all using AI in a very productive fashion. So then it can embed into a metaverse if you have simulated a city in some reasonable time, not in like 1,000 people, 3 years, much less, orders of magnitude, less effort than that and time. And then being able to embed that in a metaverse, and then you see much more applications with respect to the domains that we saw earlier. Okay. So this goes into slightly more technical stuff, but I'll just skip it. So basically what you're trying to do is to model a structure that there's a road which has so many number of lanes, which has a sidewalk, which has a car, there's a person, there's a set of people. So everything is a probabilistic distribution in ML, right? So you're saying that given a road and a structure of the road, how many cars are there, what is the position of the cars, and then obviously the various attributes of the car, where are the roads, where are the trees, the lanes, and so forth, right? The buildings around it. So this study by Professor Fiedler, they developed something called Metasim 2, which is essentially trying to replicate this reality by using probabilistic context-free grammar. But essentially it creates this structure which describes how a particular scene will look like, right? So in this road, you essentially see that you have these cars, you have the buildings, the green color, the trees, houses, and so forth. So these are kind of labeled synthetic data, right? And it is basically all generated using a particular set of models, right? Okay, so I'll quickly go through the various models that are used. So essentially here it is used to generate from a 2D image that you see in real life. Can you generate a 3D structure, which is complex aspects of the 3D structure, by using what is called a differential renderer, and then being able to do a loss across the actual rendered image and the input image, and so that you can understand the structure and create as realistic models as possible, right? So this is a StyleGAN renderer which is trying to do the same thing, using a StyleGAN to generate all possible views of the objects, which is helping to train this renderer. And fundamentally, you can model the 3D structure of these objects, and then you can use this to actually create these objects in the metaverse, which you can interact with. This is a differentiable physics renderer, which means if you in physics, how if you start modeling the whole system and the physics of interaction across the bodies, it can be a very compute-intensive system. Mass, forces, frictions, objects, elasticity, so many things are there. So what this physics engine is doing, it's a differentiable physics engine, which means you use a model to be able to, that model learns the physics implicitly, right? And you can use explainability to see how well it learns. And then you render it, you get a predicted video, you propagate the loss back, and then you see how accurate your physics engine is. So some examples here that you can see over later from this paper. This is a game GAN, which is, normally you have reinforcement learning where there's a game engine that plays the game. You see the game, running over here. Then you have a model which learns how to play the game the best, right? That is, AlphaGo and so forth, if you know of that. Otherwise, what they are now doing here, that can I create the game myself? Can I simulate the game myself? Which means a model can simulate the game instead of a software engineer actually writing that game out. So that's the game GAN. So this generated a whole Pac-Man by itself, right? And it kind of simulates the whole Pac-Man behavior and the movement of all the objects over here. And then they extended this to game GAN++ because Pac-Man is a very basic one. Now can you kind of generate these whole scenes over here? This is pretty much like a game, right? So you're now trying to simulate the behavior of cars on an actual system by just observing how it is actually happening on real roads. So pretty much you can put a camera, like a Google car driving through the streets and taking the views and putting it in Google Earth model. You can do this, and the model can pick up all these scenes and how the cars are behaving, and train this game GAN++. It starts generating the same in this virtual world or the output video. These are various techniques that are being used right now. This is one of the latest paper, which takes only one image and generates a 3D model. Right? It's a very accurate, very recent paper, April 22. These are various image generation models. I guess I've run out of time. But the latest one, all of us, or many of us would be aware of GANs that have transitioned into diffusion models, which have much higher, fidelity and, various much lesser quality, basically, measured to various metrics, FID and so forth, to be able to, generate not only through, generating images, but also from text to image. So text to image, how many of you have heard of DALL-E? DALL-E 2, DALL-E? Cool. So the diffusion models, so DALL-E 2 are based on GPT-3. The diffusion models are kind of now, improving on top of that, using a totally different architecture, which was mentioned over here through, applying Gaussian processes over there. Now these are various text to generation stuff, which you would can imagine how it would have applications in metaverse, because by using appropriate principles of text and image and giving the appropriate attention at various levels of granularity in this attention generative network, you can actually, generate that this bird has wings, is black and is small beak, white body, and so forth. So you get a very high resolution image over here, starting from low resolution images in this, generator, multi-discriminator and multi-level of generators in the process. Now we have multimodal AI models, which can, given an image and a question, what is the girl eating? It should be able to answer that question, right? So we have various types of techniques. Fundamentally, it's about feature extraction using, various CNN, ResNet kind of models or advanced models over there, encoding questions using BERT and other kind of natural language models, and then doing a multimodal fusion with attention, doing an answer prediction, and giving an answer over that, and then obviously regressing on that. Also using graph neural networks over there, You can answer various types of questions in terms of number of dogs. You can type of various relational questions. This is a very complex question. I'll take just 2 more minutes. And then there are various models over there. Federated learning is another concept where you want privacy, where you cannot get the data onto a single place. And like your mobile phones, you are using, the text completion in all of your mobile phones. All of your usage of the language is very different, right? So if we don't want to get your text data to be visible to any central server, then can we have a federated system, that can have a global model? It can, propagate and run the model updates over here, then propagate back those updates to a central aggregator over there, where your local data doesn't go anywhere. So this is a very important concept and algorithm which has been not relatively recently developed, maybe like 5 to 10 years, but it is being used in production by all the big players and the kind of software that you use. And finally, the brain-computer interface, which I described, where essentially you have a data flow through which you see how the signals from the brain are coming and how you stimulate the brain so that you can learn the various patterns of the electrical EEG signals that are there in the brain. And that's how you can pretty much answer the question. So a good amount of information is available on the net to understand the details of that. So the challenges of having AI and computer vision and other, in fact, NLP models. There are lots of NLP and speech models which we can't discuss, which might take days to discuss here. But fundamentally, the compute demand is still pretty high. Accessibility depends on the device cost, which is decreasing over time, right? But still has not gotten to that level, but will come through over a few years from now. And the industry adoption requires huge funding, awareness, what kind of business models and how it will enable and be disruptive in various verticals compared to the current traditional techniques of doing business, which is the Web 2 business models, transitioning to Web 3 business models. So finally concluding, sorry, this was a very fast talk, but so Metaverse is kind of getting realized. In some sense, it is also already there in some of these verticals that you see, like gaming and DeFi, decentralized apps and so forth. Due to confluence of these technologies across HCI, networking, decentralization, spatial, creator economy, domain apps and so forth. And it is a multi-trillion-dollar industry in the coming 10 years. So, do kind of study on that. There are lots of AI applications in this space to various verticals, which leverage across the whole development and the improving pace of development or enhancement in the models across vision, NLP, speech, and the multimodal. And fundamentally powered by blockchain over there, right? So, and there's various details over there on what type of models are there and how it really helps to solve various use cases in the metaverse when we are in that virtual space and kind of interacting in a particular context. So that's pretty much from my side. Open to questions and